Hi, my name is Mr. Chu and welcome to my study room. Today we are solving a Wassce hard math question which says that a circle x squared plus y squared minus 2x minus 4y minus 5 equals 0 with center O is cut by line y equals 2x plus 5 at points P and Q. Show that line segment QO is perpendicular to line segment PO. This question requires that we use calculations to show that the line segment QO is perpendicular to the line segment PO. But to make it more practical, I'm going to use GeoGebra to make a pictorial demonstration of the whole thing so that you can see the circle and the line where they meet and everything. Then after that, we come back to the calculation which the question wants us to use. So without delaying time further, we go to our GeoGebra to demonstrate that. Alright, we are in GeoGebra now. We are going to enter our circle quickly. And our circle is x squared right. So this is our circle. We are going to enter the lines to and see where they meet. So this is our circle and our line. And the question says the circle is cut by the line at the point P and Q. So let me call this point P. Originally, these are the first 2 points in my drawing. So GeoGebra, you have decided to call them A and B. So I'll change the A to P and the B to Q. Good, I have my point P and Q. And the question also tells us that the center of this circle is O. So looking at this equation, the coordinate of the center of our circle is going to be 1 and 2. And I'm just sharing the link of finding the center of the circle when the equation of the circle is given at the top, so that those who might not understand how I got my 1 and 2 can quickly get there and refresh their mind. The center of my circle as 1 and 2, 1 on the x-axis and a 2 on the y-axis, so that will be here. This is the center of my circle, and all the coordinates of my points are showing here. So I'm now here too is A, but then we want the question that the center of the circle is O, so I'm going to change it to O instead of A. Great. Let me connect O and P and then O and Q to get my two lines QO and PO. Alright, so I just have my line segment PO and QO, and the question is that we should show that the line segment QO is perpendicular to PO. Perpendicular lines are 90 degrees apart, so I'm just going to measure the angle between P and Q and draw my conclusion. So we take that quickly. Alright, so there we have it already as 90 degrees. Let me bring my circle down a little more and zoom it so that you can all see. There we have angle between A and B, 90 degrees. Let me bring it out for you to see. So the angle between PO and QO is 90 degrees, proving that the line segment QO is perpendicular to the line segment PO. All what I've done now is just a diagrammatic or practical demonstration for you to understand the question. So we go now to answer the question directly using calculations. Now, to show that the line y equal 2x plus 5 cut the circle x squared plus y squared minus 2x minus 4y minus 5 equals 0, we have to use the idea of intersection of lines. And the idea of intersection of lines requires that we solve these two equations simultaneously to get a point where they meet. So we are going to do that quickly. The equation of my circle is equation 1 and the equation of the line is equation 2. Normally, when you are solving two equations simultaneously and one of them is quadratic and the other is linear, it is advisable to substitute the linear equation into the quadratic equation to solve. So I'm going to substitute the equation 2 into equation 1. Substituting equation 2 into equation 1 simply means that wherever we see y in equation 1, we put the whole of 2x plus 5 there. That is what we've done. We have x squared, y, then we put 2x plus 5 there, and then the y is squared, so we squared it, minus 2x minus 4, y is here, so 2x plus 5 minus 5 equals 0. And by binomial expansion, 2x all squared is going to give us 4x squared. Then 2 times 2x is 4x, times 5 is 20x. Then 5 squared give us 25. Then minus 2x, negative 4 times 2x will give us negative 8x. Negative 4 times 5 is going to give us negative 20. Then minus 5 here equals 0. We are now simplifying further to get this and this are like terms. So x squared plus 4x squared gives us 5x squared. Then 20x minus 2x will give us 18x minus 8x is going to give us 10x. So that is what we have there. Then 25 minus 20 minus 5 will give us 0 because this is negative 25. So 25 minus 25 is 0. So that equals 0. Then here we have a quadratic equation with the c being 0. So the easiest way to solve this is to factor 5x out. And that's what we have after factoring. We get x plus 2 equals 0. And then we equated each of the two factors to 0. And x equals 0 and negative 2. These two x coordinates already tells us that there are 2 points of intersection. And the point consists of both x and y axes. So our duty will now be to go and fix each of the x coordinates into the y to get its corresponding y coordinate. So that is what we are going to do right now. We can substitute each of the x into either equation 1 or 2, but it will be easier to substitute it into equation 2. So that is what I'm going to do now. Alright, to substitute x equals 0 and negative 2 into equation 2 means that taking this our equation 2, wherever we see x, we put 0 for the first one and a negative 2 for the second one. That is just what we have done here. So looking, when x equal to 0, y will be equal to 2 times 0 plus 5, which will give us 5. And like I said earlier, our aim of doing this is to find the coordinates of the first point. So the coordinate now becomes the x value, which is 0, and the y value, which is 5. And then when x equal to negative 2, our y equals to 1. And the coordinate becomes negative 2 for the x and then 1 for our y. So these are the 2 points. This rightly agrees with what we have in our GeoGebra here. We can see that the point P, which is here, has negative 2, 1 as its coordinate, and the point Q here has 0, 5 as their coordinate. So this agrees with our drawing. And getting back to our calculation, this is our P and this is our Q. We are to show that the line segment PO is perpendicular to QO. And with that, we need to find the coordinate of the center of the circle O so that we can connect the two via calculation to show that they are perpendicular. So let's find the center of the circle now. Comparing this with the general formula, 2G will be equal to -2. And then dividing 2 by 2, our G will be equal to -1. And then 2F will be equal to -4. Dividing through by 2, our F will be equal to -2. And the center of our circle O is supposed to be -G, -F. So that is going to give us 1, 2, which agrees with what we have in the GeoGebra here. The center of our circle O with coordinates 1, 2. I just want to be comparing the two as we move on. We go back to our calculation. Now that we know the center of our circle O, we know our P, we know our Q, we are now going to prove the conclusion by the question now, that we should show that the line segment PO equals the line segment QO. And two lines are perpendicular if the product of their gradient is -1, or the gradient of one is the negative reciprocal of the other. So we are going to find the gradient of the line segment PO, then we find the gradient of the line segment QO. After that, we multiply the two to see if it will give us -1. If it does, we conclude that the line segment PO is perpendicular to the line segment QO. So we go do that using the gradient formula. And I already have a video on the gradient formula. So I'm just sharing the link at the top so that those who might not be too familiar, or those who what we are doing here will be too fast for, can watch that video at their own convenience to understand how we came by that. Alright, so taking the line segment PO, I would like to call my here as usual x1, y1, x2, y2. And the gradient formula, let me call this one M1, says that the gradient of a line is the change in y over change in x. Good. Now my y2 is 2 minus my y1 is 1 all over my x2 is 1 minus x1 -2, and this is going to give me 2 minus 1 over 1 plus 2, and that will give me 1 over 3. Alright, so this becomes the gradient of the line segment PO. I decided to call that gradient M1. And now we move on to the gradient of the line segment QO, which I would like to call M2. And it's the same formula. Y2 minus Y1 over X2 minus X1. So this, we are starting all over. So again, this becomes my X1, Y1, and this is the second point. So X2, Y2. So my M2 is going to give me Y2 is 2 minus 5 all over 1 minus 0. 2 minus 5 is -3 over 1 minus 0 is 1, which will give us -3 as our M2, or the gradient of QO. Like I said earlier at the beginning of this calculation, that if the product of these two gradients is -1, then the two line segments are perpendicular is what we are going to do right now. And let me write that before we prove. So here we have our proof. -1/3 times -3/1 gives us -1. So we conclude that therefore line segment QO and PO are perpendicular. And this is where we bring today's lesson to an end. I hope this lesson has been of help to you. If yes, then kindly consider subscribing to this channel for more videos like this. Thank you, and I hope to see you again in my study room. Bye bye.